Hello, everyone. My name is Rachit Bhargava. I used to be a platform architect for one of the Fortune 100 healthcare companies. And here's our journey of how started using Dgraph from the initial initiation of the app to the time it went live. We started with like the basic version of Dgraph, and then finally, I think we moved to 20.19.3. That's the last release that I actually worked on, and it has like a major paradigm shift from what we started and from where we are. So one of the interesting questions that everybody asks, right, that why me as a platform architect started looking at Graph as a database, right? Why can't we do everything in the relation database? So that's a kind of a battle that everybody fights when you look at a Graph as a solution for your backend microservices. And it's a kind of interesting paradigm shift from what people used to do and what we are trying to do when you trying to be truly agile and try to bring value proposition to your customers in a kind of pretty hard and fast way. So from a healthcare point of view, if you look at the data and the kind of things that we try to target from a health tech company point of view, customer or the subscriber or whatever you want to call it, right? It's the center of your universe. And when you try to look at the customer, right, if you try to visualize him or her, subscriber goes to a hospital, and then hospital he visits doctors, then he sees nurses, then he might be going for some ultrasound. So these are kind of different attributes that just originate from the user and the different activities that he or she's trying to pull. So in a nutshell, what you're trying to visualize and try to develop from a health tech company point of view, right, is a customer 360 representation of what all things he or she does. And there's nothing in the world better than a graph to do that versus relation database. Then another thing that also comes into mind, right, as you try to uh, build applications which are pretty huge, right? And enterprise level applications, you start talking in terms of relation databases, and that is where you start creating those multiple tables, right? And then in order for you to get a simple data, you have to join multiple tables and get that. And then again, because not everything you can require from a customer point of view is also always available, right? So then you start getting into those situations where, oh, I need data from table A, but I need data from table B, but table B might not always have the data, but I still need a query. So then you started getting into those queries in which you start using outer joins, inner joins, and everything else, right? That as soon as you start introducing that, that kills the performance because typical relation database index doesn't store null values, right? So when you try to execute those queries, it just becomes so complex, right? And then the query size grows, and then troubleshooting, understanding, and everything else, right? It is becomes very difficult. Uh, Another thing that we, at least from a health tech company that I was working for, one of the things that we always try to do is right is to understand what a product owner wants from their solution and the funding that they're trying to get from a business point of view, right? And always kind of, it's very helpful if they understand from the early get-go itself, being not technical, but at least if we try to present the solution to them in a way, oh, yeah, this is what you will get as a part of MVP, this is what you will get as a part of your post beta release, and this is what you will get in finally in production with limited delivery or maybe a kind of a full uh, RFLD release, right? So Graph presents a kind of a pretty easy way, and I'll just show you an example in my coming slides how actually that helped my team when we were trying to pick Graph as a solution, right? And then the fourth point is basically explaining the same thing. It just allows a neat way to stack your data and just allow everybody to visualize, oh, if I want to look at users, how many devices he or she has, right? That edge, which is a kind of an English sentence, just makes your life really easy to say, oh yeah, this user has 5 devices, 2 of them are active, third ones are not active, and fourth and fifth are giving trouble. So maybe some sort of a automation could be done on those fourth and 5 devices to replace them. So kind of a typical workflow that my health tech company went through. And one of the challenges is, right, there are so many solutions in the market. You go, right, just to Google the word graph databases, right, it will come up with like more than 100 choices, right? So then you try to figure out a way, what exactly are you trying to do from a graph database point of view? And then we basically tried to make sure, at least with the initial POC that we did with the first three first three graphs that are listed, Neo4j, DSC, and Janus slash TitanDB, is that we were kind of very interested in not to get involved with a typical graph provider. And that's the reason we were looking for graph databases which are compatible with Gremlin. So Gremlin, I mean, most of you guys know, but it's just like a kind of a overlay on top of the graph database that interacts and provides you a kind of encapsulation that you need when you talk to graph databases. So when we started looking at Gremlin by Tinkerpop, the couple of databases that came up was DSC and Janus slash TitanDB. So just Janus is like an open source version of TitanDB, which was kind of a project, and then it was scanned later. DSC is a DataStax product, which basically uses Cassandra as the database, and then of course Neo4j, which is like a true database. So when we started looking at these product rates, I mean, we did a kind of a POC, and the objectives were, if we try to do concurrency and how to get maximum value for our buck, right? And then other concern that we had from our graph database point of view is that we wanted to make sure that whatever product we are picking has some sort of an easy way for us to load our complex relational data into this graph ecosystem, and that should become a kind of a source of truth. And as we venture through this exercise, these are some of the selection criteria that we had, right? So one of them was concurrent transaction support and scaling. And then one of the kind of interesting use case that was requested by the business, right? I mean, we had to prove the value from a graph implementation point of view, right? Because if you're saying that the complex joins that the relation database produces are difficult to manage, right? And you have very complex queries, then how does a graph supports 3, 4, 5, or up to like 10 level of traversing in a kind of a very easy way, right? And then another thing was, because the kind of a health tech data, and we were talking about live customer who, I mean, in this case, for the business unit that we were trying to do the POC from a health tech company point of view, had some strict requirement on things like, oh, if this data is not updated in like a couple of minutes, then there's a chance that somebody could get hurt and even might get killed. So we always wanted to look at how quickly can we get the data back, and if asset compliance is available, it's like it's like one of the top things or the checkbox that will make us choose this product, right? Then after that, we had a couple of other things which were like future things, but we still wanted to make sure that, oh yeah, the initial deployment will be on-prem, but then at the end of the day, we wanted to use a kind of a true microservice architecture. And the reasoning behind that was that every service should have its own database, and then that is where, right, you associate a subgraph or a graph to it, and then scale up the microservice with that, right? And another important thing that we were trying to look at, which we actually realized, and that was kind of one of the reasons that Neo4j was rejected, right, is that in order for you to have a kind of a horizontal cluster, right, or you want to have more resources from a Neo4j point of view, it was, even though they say it's a kind of a masterless technology, but still under the hood, right, it was still electing a leader, and then the copy of the data was kind of same. So basically, if you have like a 5-node cluster, you're making the same copy of the 5-node of your data in 5 different places, and that's like, to me, it's too much waste spaces of resources, right? Then cost, and then the last, analytical querying. This was something that we ventured as a part of a graph solution, but that was not something that was kind of written in stone. But the most value for bug that we got from analytical querying part of, right, was from DataStax, because the Spark engine that they provided as a part of their interface itself was kind of pretty cool. Dgraph and Neo4j perform in a kind of a pretty similar way. And you want to do like basic count queries and try to do basic group bys, but then the other graph solutions are kind of pretty high. But eventually what we ended up doing is that we made graph as a source of truth, and then we used something called as Apache Druid to look at our analytical requirements, even for statistical data review. So we picked up Dgraph, and that's the reason I'm talking to you guys, right? So what made us pick up Dgraph? I think one of the key driver was it is an open source solution, and it was the fastest when we did our math around what is the concurrency, how faster the system scales up, how easy it for us to do rebuilds of the system from a backup point of view, from a restore point of view, right? And then one of the coolest thing that we found out about Dgraph, right, is the data sharding concept that was explained to us by the core Dgraph team, and we actually implemented it. So this feature basically allows you to create multi-zone clusters. And the idea is that you create those indexes in such a way that, oh, this region requires data in such a way. So then that shard of the data was only residing in that cluster. Obviously, other copies are also available. But then that created a kind of a local zoning for us to allow the users to say, oh, you are in East Coast. Most of the data that you're looking will be somewhere from the New England area, right? As an example. So that allowed us to pull data in a kind of pretty fast way. Then another thing that we found very interesting with Dgraph, right, which was kind of also available from Neo4j point of view, but the option of having commits, which is, I mean, like, because it was supporting assets, so we were able to get read commits, immediate reads after the commits. And then there was also an option in which if you have kind of a high load, there is something called as a best offer query that you can execute, which basically, I mean, the idea behind that was like to have eventual consistency, but that helped us in some certain use cases in which, oh yeah, we're running a bad job. We know this data will not be there, but then with the best effort, right, it allowed us to pump the data into one side of the cluster, right? And then we knew that it's not going to be sent to other clusters till it's available, right? Because of the best effort. So it allowed us to write pretty big data scaling system with batch processes with eventual consistency. So it didn't put much load on our prime main machines or the leader, right? And the data was actually being pumped into the non-leader clusters, and then we were able to get them. Then the third is kind of a pretty important, as I was saying, is that we wanted to seed the data into our graph database as we were trying to get in, right? And we went through multiple exercises with the Dgraph folks. I mean, initially they were only supporting the RDF-based load, but then they worked with us and they provided us a way to load the actual JSON data that we extracted using our processes, right? And we're able to load them. Then a bunch of other things like indexing with native reverse edge support. So if you go for a kind of a traditional graph, right, like for example, you go for Neo4j, you have to explicitly define a reverse edge as you are trying to do any data loading from a graph point of view. In Dgraph, I mean, reverse edge is just like a annotation that you can add as the time when you're creating an index. Security aspects with RBAC. See, these RBACs are kind of a term that I stole from Kubernetes, but at least in terms of Dgraph, right, more specifically, I'm referring to ACLs, which came as a part of our Dgraph's enterprise solution. Pretty useful thing that, I mean, in the beginning, it was kind of not there, but as we grew from our product point of view, plus from Dgraph point of view, right, everything started adding together, and that allowed us to have like granular RBACs or ACLs to allow the user to say, oh, you have only access to this predicate, not to anything else. If you don't have access, then you will not be thrown an error, but what you will end up seeing, right, that nothing is being returned. So that basically allowed us to have everybody access to this new tool in our production ecosystem, and then also made sure that we are not getting into those issues with HIPAA, or to say, oh yeah, this guy should not have access to this data while he or she is looking at somebody's SSL, even though it's loaded in Dgraph, right? And then I think the last thing basically summarizes what I was trying to talk about from a bulk loader point of view, is that out of the box JSON support. So one of the things that people don't realize, and it might sound kind of pretty trivial, but when you do API development and when you create hundreds and hundreds of them, right, you would like to use a system in which you don't have to use Jacksons or the JSONs of the world to do your data formatting. And what I mean by that, right, is that still we have not left the world of writing those plain old POJOs. So you still query the graph, you convert that to an object, right? And if something is coming out of the box, and Dgraph is kind of pretty flexible with the annotations that they provide, right, as a part of their GraphQL ecosystem, it makes life real easy to say, oh yeah, here's my class, here's the output that I'm going to consistently get in a JSON format. And there's no need for me to write a custom parser to look at the data that I need as compared to what we have to do for even for something like a DSC or for Neo4j. So in my previous slide, I was talking about how and why we were trying to use Graph, right? So one of the reasons why we wanted to use Graph, right, is to make life simple for the product owners, right? We want to tell them this, their requirement, whatever they need. At the end of the day, obviously, it will be written in some sort of a language, right? But if you make the use cases simple so that they know what exactly are they getting, right? So for example, we modeled our graph database and the APIs around it, right, using simple English sentences so that when we communicate to the product owner, right, we say, oh, this API will do this, and this is the model or English sentences that will use to say to get to your requirements. So the product owner say, I want to create an app in which user should have access to Care Circle, they belongs to Care Circle, and they do blah blah with that Care Circle, right? They have to pay for a bill. They can use the different methods to pay for a bill, right? And then they will have devices. So when we started writing those GR stories, and when we started to onboard the developers as well as different teams, we presented them with these kind of English sentences as a part of modeling to say, yeah, you said user should be a part of a care circle, right? So in our case, it will be like user belongs to a care circle, and it kind of ties pretty well with the modeling that Dgraph supports, which is like subject predicate model, right? And they keep it simple. We also try to keep it simple. So the user belongs to care circle. User pays bill for a service. User uses payment method to pay for bills. User has devices, and then the chain goes on and on and on, right? And the key thing over here, right, as the conversation started, user is our center of our universe, right? So everything starts with universe, and it's not saying that you can't say devices have some other attributes, right? Or care circle have different roles, right? Or service is a premium service or a kind of a secondary service, right? So all those kind of possibilities are there, right? But it just makes it really easy from a user point of view and from a developer as well as a product owner point of view, right? That how my data is getting stacked and how I'm trying to build this interconnection, because it's always easy to relate it to something that we live and breathe every day as compared to writing a requirement says, oh, go to this table, fetch this, and this column will have this. Well, like from a product owner point of view, they care less how the data is being stored. All they need is, yes, I need these 4 attributes, right? And they will be there. And another thing with Graph that it's kind of inherently not visible is the flexibility with data model, right? Because Dgraph supports JSON out of the box, it allows us to add and remove attributes at will, right? Okay, so I kind of a pretty simple example of from these English sentences that we had, right? We created a kind of a logical model, and that helped the business partners, right, and the product owners to visualize what and how the application is going to interact, right? And then it kind of presented a pretty clean clarity from application developer point of view, right? To say, oh, I want to write this user service. Oh, and by the way, it needs to have a connection to this care circle. So when I'm modeling my class, right, I need to make sure that there is a way for us to add this edge belongs to, because that's what my English sentence says, right? It said user belongs to care circle, right? The user has devices, user uses payment method, right? So whenever we have these kind of arrows going from this user to a payments, right? This arrow going towards the payments node, that's the edge, and by default it is a reverse edge also, so you can query in either direction without having any sort of penalty, right? And this provides us so much flexibility. Like for example, right now what you're not seeing over here is a kind of a complete data model, but the opportunities and the flexibility that this provides is enormous, right? So in future, if user has devices and user is trying to subscribe to devices which are not from the healthcare provider, they are third-party devices, right? Then all you need to do is, right, you need to add another node which is of type has device, and then create some attributes which will define that it's a kind of a different device. It could be a node or it could be an attribute that can sit on this devices node itself, and you just use them as they require, right? And then with as Dgraph is evolving, it also allowed us to, patch data, or we were able to kind of write pretty simple Python scripts also to when we had to move data here and there by using the PyDgraph library that we got from Dgraph. Challenges. So one of the things that comes with any new system that you're trying to bring in from your legacy enterprise point of view, right? So working in a kind of a startup, it's kind of pretty easy. You're starting with a green field and things are and whatever you want, right? And if there is a mistake, you just go say, oh, I'm going back to drawing board, right? And let me start it fresh because there's no baggage that I'm carrying. With respect to legacy, huge legacy and Fortune 100, Fortune 100 companies, the legacy enterprise systems, right, they don't go away. So what you try to do is, right, you try to find a way of how to make them understand that, yes, relation was the way, but there are certain things that you could do in NoSQL databases, right? Right, which doesn't mean that, oh, I want to have my billing system also run out of Graph. No, Graph is not designed to support a billing system, right? At least in my opinion. But what Graph can do is to create that logical uh, collaboration between different business entities so that you know where your data is sitting and how is the best sorry and what is the best way to reach out to it in a way, oh yeah, I know this patient data is over here, this device data is over here. If I just create an edge between these two nodes, right, and I should be able to get each and every information from this, and that becomes my source of truth as compared to going to hundreds of tables and try to find simple uh, answers to your basic questions, right? As we were working with Dgraph, right, we had some challenges with respect to best effort queries, right? So even though it's a kind of a consistent system and it's support asset, but in some cases, what we observed, right, and that is in the kind of initial versions of the Dgraph and maybe with the latest one, right, is that the best effort queries were not returning us all the data. And the problem with that was we had a pretty big live application in which there were thousands of concurrent users. And if the data was going here on the right, not saying that it was impacting each and every customer, but in some cases we saw that the data that we had on one node was kind of different from the other node, right? And then the third point is basically describing as we go through with the new product, right? And the challenges are we learn with them and the team that you're working with, right? Also learn with us. So we started with Dgraph right from the very basic version, right? And then once we moved to production, it was a kind of a pretty big and hefty exercise for both the teams for us to go to the latest 20.3 releases so that we are using the latest and greatest version of Dgraph. Right? The analytical queries, as I was describing, one of the criteria for us was to look at the analytical stuff. I mean, Dgraph did what it can do, but again, it was not as impressive as what we had with DSC, but it did the job. And then finally, when we were able to integrate our solution with Druid, it helped quite a lot from just creating a pipeline to extract the data from a transaction Dgraph and that put into some sort of a warehouse, right? Maybe in future there might be a tool that that will be requested from Dgraph and it might be available, right? Last dataset migration. In the initial phase, we had pretty huge data, and then the only format that was supported was RDF. And while we had own challenges with converting from JSON to RDF, right, or write that, we worked with the Dgraph team, and then finally they were able to provide us a JSON library that allowed us to do that huge data migration. And when I'm talking about huge data migration, I'm talking in terms of terabytes of data. It was not like a couple of GB data that we are talking about. We're talking about a couple of terabytes of data. And that too is a kind of a transform way, because one of the things that you try to do is, right, you try to take your normalized data and try to denormalize it as much as possible from a graph point of view so that it provides you flexibility, and then whichever way you want to query it, right, makes it easy, right? The second last item was kind of a wish list from our product team, because one of the things that large enterprises do, right, is that most of their core reporting comes out of the existing legacy solution. We move to clouds and use solutions like Redshift, etc., etc. But again, it's RDS underneath, right? So right now, the request was always, oh, you have all the data, you are the source of truth, right? But I still need some sort of a pipeline to extract the data and put into some sort of a RDS solution, because there is no direct interconnection between NoSQL to databases like Dgraph, right? With the reporting tools that people use, like Tableau, or what was there's one more that we use, right? So it's a kind of work in progress, but something that we had like initial, like back and forth with the architecture team to say, oh, yes, it's checking on 5 boxes, but the seventh one, it's kind of important. But then we have to come up with like creative solution of writing pipeline and then dump the data. Then the last one is subgraph for logical separations. So this was kind of partly resolved using the ACL that came in the enterprise version, but in the initial phase, right, we had to go with like a big holistic dgraph, and then uh, have the own node types embedded, and we have to write our like own custom ACLs in our application microservice code, so that it knows, oh yeah, I'm trying to write to this guy, but if I can only talk to this node if I have this, right? And I need to make sure that this is not overwritten when this workflow is kind of requested. So ideally, from a microservice point of view, right, the way you try to visualize is you try to have their own independent databases. So that's something that we were looking from a subgraph option for doing logical separation. But it was kind of partly achieved using ACL. Maybe it's some sort of a work in progress. And here is an example of what I was trying to explain with kind of a complex join from with multiple tables as compared to kind of a sample query that basically uses the logical model that I showed and use all the kind of bells and whistles in a kind of pretty straightforward way from a dgraph point of view. So in a nutshell, what this query is what it's doing is, right, it's trying to say from application point of view, I'm trying to log into my app, right? And as soon as I log in, right, I want to see who all people are there for this user, which belongs to my care circle, right? And then once you get that information for all the people that belongs to your care circle, you try to find their name, who's the guy who's getting the service, right? And then who's paying for the service. And then you can add as many blocks of GQL that you need, right, to get more and more data, right? And the cool thing with all of this is, right, it comes back with a JSON. So we were just saying, oh yeah, comes like this. There were classes that were already defined and were readily converted to kind of a Pojo. And that's pretty much it. Thank you for listening in.